Hello friends, in this video we'll go through Softmax activation function. So this is lecture number 8. In lecture number 7 we have discussed ReLU activation function. So in this video we'll go through Softmax and numerical of Softmax activation function. So what is softmax activation function? It is mainly used in output layer of the neural network. So while ReLU is used in hidden layer neural network, and it is mainly used for multi-class classification problem. So it converts the raw output value into neuron called logits into probabilities. Means a neuron produces some output that is called as logit, and then softmax function is applied here, and then probability is calculated. So whenever there is multi-class classification here, there are we have to identify whether the given image is cat, dog, or what. So first of all, we have to calculate the logic, then softmax function is applied, and then probability is calculated. The higher probability will be selected. So here the probability of cat is 66. So that's why the output will be 66. So this is how the softmax function work. So here, first of all, there is logic, and then we have to apply softmax, then probability is calculated, then we have to predict the class. So this function is very popular for multi-class classification. So example here, here is the detailed example. Suppose we have to identify whether the given image is cat, dog, or bird. So first of all, we have to pass the image, then at the output layer, we have to calculate logic. So here the neural network produces output, let us say this one. Then we have to apply a softmax function which is given, that is we have to apply formula, and then this probability is calculated. Then the entity having highest probability will be selected as output. So this is how the softmax function works. Now, formula for softmax. So, for suppose a neural network produces n output values, that is Z1, Z2, Z2 up through Zn. The softmax function is given as S of Zi is equal to e raised to Zi upon summation of j is equal to 1 to n e raised to Zi. So, what is Zi? Zi is the input value or logic for class I, Zi, that is exponential of the input, then summation of j is equal to 1 to n e raised to power z j. So sum of exponential of all the output value, and then s of zi is probability of class I. So this is how the softmax function work, and this is how we have to use the formula of softmax activation function. So here is the example, detailed example. Suppose the value of z is 210. Okay. So this is called as logit. One more important thing is once you calculate the probability value, then output, if you do the sum of all the probability, the output will be 1. So first of all, now we'll go to second step here. Apply the exponential function. So e raised to power 2 is 7.389. E raised to power 1 is 2.718, and e raised to 0 is 1. So therefore, this is the input vector. Now calculate their sum. We have to calculate their sum. So sum is 11.107. Uh, Now next step is we have to divide by each component. So here we have to divide 7.389 divided by 11.107. So it is S of Z1 is 0.665, S of Z2 is 0.245, S of Z3 is 0.090. And then we have to apply the softmax function here. So after applying softmax function, we got this value 0.665, 0.245, 0.090. So here, if you do the addition, the output is 1. So here the 0.66 is maximum, that is having highest probability. So this is selected. So this is how the softmax function work. Uh, so I hope you understand this example. Then softmax in neural network. Next is softmax in neural network. So first there is input layer, hidden layer, output layer, and at the output layer softmax function is applied. So here there are 10 neurons. So Z0 to Z9 having this logic. So this, now next step is we have to apply softmax function and calculate the value. So if you do the addition of these probabilities, addition of these outputs, you will get 1. So here 3 is having highest value, that is 0.89. So predicted class will be 3. So this is how the softmax function work. Now, why do with exponential function? What is important? Because all the output become positive because e raised to x is always greater than 0. So softmax probability can never be negative. Okay. Next is it emphasize on larger values. Suppose the logits value are 1 to 3, then exponential values are this 2.718, 7.389, 20. Okay. So uh, small increases in larger logits result in much larger exponential value. So that's why we use exponential value here. Next is the output lies between 0 to 1. So if you calculate the softmax, if you do the addition of softmax values, the output is 1. Okay, sum of probability is always 1. So the property number 2 is sum of probability is always 1. So this is the second property of softmax function. Next is highest logic get the highest probability, means the if the logit value is higher, then its probability higher and definitely that will be selected. Then outputs are interdependent. Unlike the sigmoid activation function, softmax inputs are also connected to each other. So this is the example. Probability distribution before change is 0.4 class 1, it is 0.40, 0.30 for class 3, 0.20 for class 4, 0.10. Then after increasing, it can be 0.50, 0.25, 0.15, 0.10. So softmax output are interdependent to each other. Um, so this is the fourth property of softmax function. Then softmax for multi-class classifier. So how it is used? Suppose we have to identify whether the given fruit is apple, banana, or orange. So let us say network produces output 1.2, 1.5, 3.2, 0.8. So then we have to apply softmax function. Definitely this value will be higher here. So that's why we can select is that the given fruit is banana. Uh, that's why the softmax function is applied at the output layer. Now, what is the advantages of softmax function? It produces the probability. The value are always probability and highest value will be selected. It is most suitable choice for multi-class classification, and it will produce normalized output, that is summation of all probability is always 1. So that's why this softmax function is selected at the output layer. Then limitation is not sensitive for multi-label classification. If the image can belong to multiple classes simultaneously, independent sigmoid output are generally more suitable. So sensitive to very logit value. If small change in logit value can produce big exponential value, then overconfidence network can sometimes produce very high softmax probability. Even when the prediction is incorrect, that is also limitation. Numerical overflow. Direct calculation using large exponential value can cause the overflow in the network, and that is why softmax implementation is used. So where it is used. So these are all limitation of softmax function. Then let us see the classification, or sorry, differentiation between softmax, ReLU, sigmoid, and 10H. So all these are already covered in previous lecture. So output range of softmax is from 0 to 1. Then ReLU it is 0 to infinity, sigmoid it is 0 to 1, and 10H it is -1 to 1. So my suggestion is go through this activation function videos. So softmax is used in multi-class classification. It is used in hidden layer. It is used in sigmoid is used in binary classification, and 10H is used in hidden layer. Then pros is, that is advantage is probability sum is 1. ReLU is very simple, fast, okay, and solve vanishing gradient problem. It is all sigmoid is smooth, differentiable, and tannage is zero centers, smoother than sigmoid. Is the output is from -1 to 1. And then softmax disadvantage is it is not ideal for multi-level classification. ReLU, there is dying ReLU problem. So we have gone through the various types of ReLU. Then disadvantage of sigmoid is vanishing gradient problem. it saturate easily. And in 10H also there is vanishing gradient problem. Here you can see there is saturation. Okay, so this is the comparison. Now next is softmax is again best used for multi-class output. ReLU is used in hidden layer. Sigmoid is used in binary output, and 10H is used in multiple layers. So here, softmax you will get probabilistic output. In ReLU you will not get probabilistic output. Sigmoid you may get probabilistic output, while 10H you may get probabilistic output. While 10H is zero center, while others are not zero centers. Then vanishing gradient problem. Then sigmoid and 10H are suffered from vanishing gradient problem, while ReLU is not suffered from vanishing gradient problem. And softmax sometime it is suffered from vanishing gradient. So, and last point is computational cost. For softmax, computational cost is very high since exponential function is used. For ReLU, computational cost is very low. Sigmoid is also low, and 10H is very low. So, ReLU is most efficient in computational cost. So, this is the differentiation between these four activation function. Now, that's it for this video. I do hope you understand softmax activation function. If you like the video, then please subscribe, like, and share. Thank you.